Hello, sixth period. I'm not in class today because I am in a meeting downstairs in room 109. Do not come find me, please. Please make sure, though, that you continue to watch this video and that you're good on it, on what our stuff is for today. If you would like, you can have somebody do the Fun Fact Friday cards. They're in the room. They're by the computer screen, so feel free to do that. I know Kate would really love to do Fun Fact Friday. But other than that, we are not going to take homework questions from yesterday, because that homework is not necessarily due. That homework is due on Tuesday when you return. Right now, we're not going to do cross sections. We are going to do integrating with respect to y's. Y's? Why? Why? Good question on why we should be integrating with respect to y, and you're going to see in just a minute. Okay, was not expecting this slide, but here's me in high school. This was in 2002. And here's me in my first year of teaching. I don't know why the shirt was so baggy and brown. No idea. That was my first year teaching. I showed this slide last year because there were students that needed inspiration, and I don't know if this picture sufficed. Next. All right, area between curves perpendicular to the y-axis. So notice here we're not looking at a top minus bottom anymore. We are instead looking at integrating with respect to y, not x. So we're going to be looking from right to left. Right to left. Okay, so this sentence says everything that's basically on the graph. And what we're going to do here is we're going to set up an integral from smallest number to largest number, from c to d of f of y minus g of y dy. And again, the reason we're doing f of y minus g of y is because if I shade all this area between the y-axis and the function, and then I cut off all of this area by the line, bye-bye, then that means I'm doing a right minus left function. The rightmost function minus the leftmost function. And that's what I'm going to write here in the next box. So a different way of writing this is going to be from C to D of right minus left. Right minus left. Okay. Now the other thing you need to be aware of, these are y equals for both of these. Y equals for both of these now. When you integrate with the y's, you're integrating with respect to y, so it's a little bit different than integrating with respect to x. So I'll just make a note here. Integrate with respect to x, that's going to be top minus bottom. Or I think in ours had top minus butt. So top minus bottom dx, that's the one. And then in the one that we're doing right now, we do left and right when we have y. So for what we're doing right now, we have, I'm sorry, right minus left. I said left minus right. Oh my gosh, that's horrible. Why did I do that? Right minus left dy. Okay. So let's write an integral expression for each of these. Now, I would recommend that you pause the video and please try some of these on your own before you just see an answer. I would be super careful with this one. And yeah. Okay, go ahead and please pause the video and try those on your own. Thank you. There's a really annoying person around here that was humming. I don't know why. But anyway, so here's the answer for the first one. We got the integral from y equals c to y equals d of f of y minus g of y dy. If you're not sure why, why? As this is the rightmost function, so that's right, minus left, the leftmost function. Dink, 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 minus left. Okay, so that's first. For the second one, we'll go to the purple one here. Same idea, the right minus the left function, the blue line is going to be the right side. So we'll set this up as y equals negative 2 to y equals about 4. Y equals 4 of the right minus the left. The right function is this one. I'm not going to write that in here yet. And the minus is going to be for the red And the red is going to be 1/2 y squared minus 3. We are going to put a dy here because our integral is with respect to y. And this other part is going to be not x minus 1. In fact, it's going to be y plus 1 because you need to solve for x to get the integral in terms of y. So we'll write that at the top because that's super, super important. Maybe we'll write on the side. So let's do it. When integrating with respect to y, please make sure your equations are in terms of y, which means solve for x. Okay, let's go and just rotate this one. Let's rotate this one. Rotate. Whoa. Let's go and move this over here. Let's just decrease the size here. Okay. Let's decrease the size a little bit more so we can read it all on one side. Okay. So let's go and try the next one, bottom left. If you haven't already done so, please make sure you're doing that while I'm trying to figure out how to work a computer. All right, this is not working. I'm just going to do it this way. Okay. No, I'll just do it this way. That way anyone that really gets upset by that can get upset by it. Okay, so now let's go and do the next one here. It looks like the next one is going to be starting at y equals negative 1. So that's where we're going to start. Y equals negative 1 to y equals 3. It's not really apparent that I want to actually integrate this with respect to y. The reason I'm integrating with respect to y is because my functions are written in terms of y. So that's a good hint to integrate with respect to y. So y equals negative 1 to y equals 3. Let's do right to left. The rightmost function is going to be this blue one. This is the rightmost function the entire time. So it's going to be negative y squared plus 10. And then we're going to subtract from it. So that's the rightmost function. We're going to subtract from it the red function, which is the leftmost function the entire time. And that is going to be y minus 2 squared. Please also note I am not taking the time to set these up. I'm not taking the time to solve these because that's going to be your responsibility. Sometimes you just have to set up. Last year they asked you to actually solve them. So again, use caution in that regard. Okay, so that was those three. So now what we're going to do is this last one. This last one says to this bothers me that this is like this. Don't stop doing that. Stop. Go away. Go. Oh, no. Stay there. Okay, and now escape. Ooh, dy. Okay, that box is going to be there forever and ever. So now let's go and do the next one. Oh, now it's gone. Okay, we can integrate this with respect to y because this area is right against the y-axis and it looks easier to integrate with respect to y. So let's do it. Let's go and set up our integral from y equals 1 to y equals 3, smaller number than larger number. And we're going to do right minus left. The right one is this one, but we need to solve for y. And I think that is y squared plus 2 to solve for, we need to solve for x, which is y squared plus 2. And then let's also make sure that we know that the other equation that we're using is this purple line here. That's the other line, x equals 0. So we get, sorry, I was just looking at something. So we're going to get rightmost function, which is y squared plus 2. And then we're going to get minus 0. So minus and then 0. Minus 0, 0, 0 purple, and dy. Okay. Before we go on with this, what I'm going to have you do is rewrite that problem in terms of x. Please see if you can figure out how to do that. Rewrite this integral in terms of x. Please pause the video and try to solve that now. Nice try. Not showing you yet. Please try to solve this integral Find this area in terms of x now. You need a rectangle. You need that rectangle. Now I know you can tell me what that area is, but if we were setting up an integral for this and not trying to solve it, we would get the integral from x equals 0 to x equals 2. So this looks like this is 2, but if we plug 2 in here, we would get 2 minus 2 is 0 for limit of integration, which is not right because this value should be at 1. So instead, what we could do is we could solve for x to find out what the value is. The graph is not reliable for us. And if we square and add 2, we get 3. X equals 3. So we're going to integrate this from x equals 3 x equals 0 to x equals 3. So let's try that. X equals 0 to x equals 3. 0 to x equals 3. And again, I'm finding the green area right now of top. Now the top part here is this blue part minus the bottom part is this purple part. So top is blue, which is y equals 3. So we have a 3. We have a minus bottom part, which is 1. And I know that's 2, but this is how you would set up the first part, dx, plus we need another integral for the second part, which is going to be this orange part. And this orange part is going to be found with the top part, which is 3. So let's go and do x equals 3. We'll hold off on the upper limit of integration, x equals 3. And the top function, again, is going to be this color here, which is this lovely color of whatever that is. So 3 minus, let's pick a different color here to just go crazy with colors, is this part is the bottom part. So top minus bottom is going to be square root of x minus 2 dx. To find this other value, the top limit of integration, we need to set our integral, we need to set our equation 3 equals square root of x minus 2. And if we solve that, is square both sides and add 2, we should get 11. So x equals 11. If you've solved this integral, you should get the same exact value as you did in this integral. So it seems pretty apparent now there is an advantage to solving with respect to y versus x. But please pause this video and copy this down so you know it, the advantages and disadvantages, of course, of integrating with respect to y and respect to x. Please note, it might be easier based on whatever functions you have. I've seen some integrals where if you try to integrate with respect to x and you get 2 integrals, and then you change those to y's and integrate with respect to y, it's just as difficult. So it's not always simplifies. It doesn't always simplify the work for us, but sometimes it does. And now we're going to go on. That's just a note. This came up in third period, so how do you integrate on your calculator with respect to y? The calculator doesn't know any difference between y and x. So if you put x, you'll still get the same answer that's intended. And then finally, let's just set up this one, and I think we'll call it a day. For this last one, you're welcome to look up the answers online. But I want to say under 15 minutes here. So for this last one, to set up the integral, it's going to be the integral from, again, smaller number, y equals -1 to y equals 2. The reason I'm choosing y, by the way, and not x is because I have a function in terms of x. So I also notice that if I try to integrate with respect to y, the top minus bottom is kind of harder because the top minus bottom is one thing here, but then also a very different thing starting there. And if that makes sense to you, if it doesn't make sense to you, integrating with respect to y is the best bet. So y equals -1 to y equals 2 of right minus left. The right one is going to be this function, which is y squared. Then we have to subtract off this one, which is going to be the blue function, which is, and I did that wrong. Oh my gosh, thank gosh you guys weren't here to see this in class and ask for extra credit. Oh my gosh, this is embarrassing. Okay, so now we'll get the purple function as it says, y equals x minus 2, but it really should be x equals y plus 2. Okay, put parentheses around that, put a dy, and then you can integrate that on your own, and you should get the answer. Check the answer on the calculator. Thank you for watching, guys. Make sure you get your homework done. Thank you.